All right, so this is Unix Programming and Tools, CSE 224. It's the first of a 3-course sequence in computer science here, which is 224, 222, 223. And those are offered only in fall, winter, spring. So you're in the right place if you're doing computer science, because you can't take this course anytime other than fall. So I passed around a couple of pieces of paper. The first one is just kind of a general information sheet. This is just for me to have for reference. So basically, whatever name you want to be known by, right, a nickname or whatever you prefer, I call you, go ahead and put that on the top. If you have a preference for pronouns, go ahead and put that down. Otherwise, I'll use whatever one seems most obvious to me. Also, give me your name as it appears in Canvas, okay, so that I can map you to the entries for grades and assignments. And then I want some information kind of telling me sort of a little bit about you, self-assessment. How comfortable would you say you are with Linux? Now, you use Linux in CSE 121, but working in a Linux environment, being able to move around, find files, things like that. Self-assess, 1, not very comfortable at all. 10, you live, sleep, and breathe in the Unix environment. You're completely comfortable in it. Just sort of where you think you are with that. How comfortable are you with programming in general? Same scale, 1 to 10, where 10 is, again, you think in code. And 1 is, I got through 121, but I don't really know what I was doing. I sort of was really lucky that I passed, I think. And then how comfortable are you with programming in C in particular? Okay, which is a language you spend most of 121 in. Do you have a laptop, in particular a laptop that you can bring with you to class? And if so, what operating systems? Probably either Windows, Apple, or Linux, or maybe a Chromebook. And are you planning on bringing it to class? It's not necessary, and in fact, you're probably better off without a laptop in front of you. But I kind of want to know sort of where people are with that. And then same thing, do you have a desktop system, say at home, and what operating system? And then whatever you want to write, just kind of like what you're hoping to get from this course. And if you're taking this just because it's required and it's on your plan of study, that's totally cool. But if you've got some reason that you're hoping to, learn more about Linux or about programming in C or something like that, feel free to share that up there. And you can fill this out now, but you can also bring them back tomorrow if you like, so you don't have to take class time to think about those things. But you can bring them in tomorrow and I'll collect them. All right, I've also been asked to read a statement. And this is a call out for somebody who's willing to volunteer as a note taker. So a note taker is basically someone who's willing to take notes, but make them available to a student in the class. So I've got a particularly worded statement I've been asked to read. So a student in this class has a documented disability that impacts his or her ability to take comprehensive lecture notes. The Disability Support Services Office is requesting that someone, preferably 2 of you, volunteer to share your notes. You do not have to do anything different than what you would normally do for yourself unless you choose to. The DSS office will provide you with NCR paper, which is carbonless, 2-part, 3-hole punched, lined notebook paper. It's really cool stuff. After you've completed the class for the day, you keep a copy and give the student with the disability the other copy. This way you do not have to go in search of a copy machine. If you'd rather not use this free paper and want to use a copy machine, DSS will make copies for you. So basically, you take notes, you just use it on special paper, or you take your notes on your own paper and give them to DSS, and you just give a copy to the student when you're done. So, is there anyone who would be willing to volunteer his or her notes? Okay, you'll do it? Cool, okay. I still have to get the packet from the student. Once I do that, I'll give you each a packet of this notebook paper and make arrangements so that you can give a copy to the students. Awesome. All right, thank you very much. can fill out and just bring back tomorrow. And it's just kind of an information sheet for myself. All right, the other thing I've handed out to you is just kind of a handout that I stumbled across a while ago. It's got nothing in particular to do with this course. This is actually from Chabot College. But it's got everything to do with my philosophy on programming courses. You can fill it out and bring it back tomorrow. This was a one-pager I found called How to Pass a Programming Course. And I tend to get wordy sometimes, and I've been writing longer and longer intros to this course describing how people can be successful in this. And I stumbled across this last year. It's one page, and it kind of hits all my main bullet points. So it may not apply 100% because it's from a different course, different college. But let me just run through these really quickly, right? Come to every class on time, every time. Some of us are walking from the other side of campus, so you're going to get here a few minutes late. But as much as possible, come here close to the start of class, and don't miss classes, okay? I don't take attendance for the sake of grading, but if you miss classes, your grade is going to suffer. That's just a reality. Okay, you really got to be here and you got to be engaged to be as successful as possible. I suggest avoiding technology while you're in here, which might sound kind of like an irony, but the more you can sort of stay present and focus on what's going on and actually think about the things that we're discussing and engage in the conversations, right, again, the more successful you're going to be. And that's kind of point 3 here also, right? If you have a computer with you, right, you can use it to take notes, but you really can't beat pencil and paper. We're getting closer to where we can use a tablet and a stylus, and it can be almost seamless, but it's still not as direct as pencil and paper, right? There's just fewer distractions, fewer things that go wrong. Go over your notes immediately after class, right? While things are fresh in your brain, think about what you're doing, what we talked about, questions that come up about whatever subject we're discussing, and work with those. We're going to talk about that in a few minutes because I have some tools to help you do that. But don't come to class and take notes and stuff them away and plan that on the weekend you're going to go back and look at your notes and think about what we've done. Right? 5 days is a long time. It's a lot of material. And if you're confused about what we're doing on Tuesday, Wednesday's going to be worse, right? Because we're generally building on things. And by the end of the week, you're going to have basically lost a week worth of material. And it's a bad hole to try to dig out from. Do your programs yourself. And this is one of the biggest reasons why people struggle in this course, in the whole CS sequence. It's okay to work with friends. It's okay to work in groups. Group programming is really fun, okay? But it's really, really important when you're sitting down and you're trying to write a program that you go through the process of starting from nothing with just yourself and your notes, and you go from there and build up a program. And if you're working with a friend and you say, I'm not sure how to do this part of the program, can I see what you did? And you look at their code, that's in your brain now, right? You can't unsee that. And when you sit down and you try to write your version of it, you're going to be modifying what you saw, basically. And you'll get a program that works, but when you're on a test or on the job, you don't have the benefit of that, right? You really got to take it from inside and from your own abilities. And you're not going to develop those unless you get through these barriers of, I don't know how to start, or I can get to this point, but I don't know how to get beyond that, right? So you really, really got to make sure you're doing your own work, right? And it's not over cheating I'm worried about here. Like, give me your program, I'll give you $5, right? It's this very subtle looking up an algorithm on the web, right? And okay, now I know how to do it, and so you go ahead and you code it, but you didn't really actually figure it out yourself. And that'll come back and bite you. Same thing, if you had me with 270, we laughed about this also, right? Don't copy and paste. It's a pain to write number sign, include angle bracket, stdio.h, close angle bracket, over and over and over again. But after you've written it a few thousand times, I guarantee you're never going to forget it, right? And when you want to write some other include directive, you can modulate that and you can do that. The starts of the programs are always the same. the way that you compile a program is always the same, but get in the habit of doing it from scratch, right? So that eventually it becomes second nature to you, how to start a C program, how to compile, how to edit, all of that stuff. Number 8's the biggest one. Okay, this is the biggest thing for the entire next 40-some weeks. To know how to program, you've got to understand algorithms. Okay, programming is all about algorithms. What's an algorithm? It's a recipe. It's a step-by-step description of how to do something. There's an algorithm for coming to school in the morning. Right, you wake up, you turn off your alarm, you brush your teeth, you do this, you do that, right? It's a series of steps. If it's raining, then I grab this from my closet. Otherwise, I grab that, right? Conditional statements. Programming is all about algorithms. It's not about if x equals 5, then go to this or call that. It's about knowing how to take a problem and describe it as a series of steps. Once you know how to do that, once you have a series of steps, now you turn that into a program, a thing that a computer can translate into machine code, right? That's kind of a mechanical process. That you do it a few times and you just sort of get into the habit of, oh, when I want to make a conditional, I write this kind of statement. It's really all about algorithms, and we're going to spend the first week probably working on algorithms. Okay, without reference to C or compilers or Linux or anything else. So keep that in mind. All right, so you can read the rest of those at your leisure, which is stuff to keep in mind. So let me hop through the Canvas entry for this course. So does everybody here have Canvas access? Okay, if not, come and talk to me as soon as possible because we make heavy use of Canvas here. Switch views here. Oh, I didn't introduce myself in the beginning. So my name's Nick. I teach computer science and electrical engineering here. Some of you have had me in other courses. Some of you haven't. But my basic information is on the syllabus. Probably the main thing you want to know about me is my email address, because if you can email me, you can ask me any questions about any of this other stuff. So nmacias@clark.edu gets you to me. My office is right on the other side of the collaboratorium. That's that big lab space in the middle of the building. If you walk through that, the first door you find on the right is Izad's office. The next door is mine. I have office hours posted on my door. You can also find hours for myself on engrcs.com/schedule. Mostly it's 9 to 10, Monday through Friday. But I'll also be in my office usually from 12 to 12:30, Monday, Wednesday, Friday, right before CSE 215. Let's see, so learning to use a Linux operating system with a focus towards using it as a development environment, blah, blah, blah. You can read all of that, okay? Basically, it's a course on the following things. 1, working and being comfortable in the Linux environment. Okay, Linux, Unix, kind of the same thing. But working more with that environment. So that's one thing. 2, it's a crash course in C programming to get you ready for CSE 222 in winter. 121, you get introduced to C, you learn a bunch of different aspects of C, but sometimes people come through 121 and they're like, wow, I'm so glad I survived that. But they don't really feel like they know how to program very confidently. And sometimes 121 was a year ago, sometimes more than a year ago, right? And what we found was that going from 121 to 222, which is the data structures course, was a huge jump for a lot of people. 224 used to be at the end of the sequence, right? 22, 3, 4. Now it's in the beginning because it's kind of a bridge from 121 to 222. So this is your chance to get really, really, really proficient in C and in programming. So that's the second part of it is advanced or intense practice with C programming. The third part is intense practice with debugging. Okay, getting really good at taking a program you've written that doesn't work and figuring out what's going on. And this is a really essential skill for success in programming, because sometimes you write a program and it works the first time. That's great. You go home early. A lot of times you write a program and you run it and it blows up, or it does nothing, right? And what do? Well, it's like in 250, you build your circuit, it doesn't work. Do you rip all the wires out and start over again? Some people do. But it's nicer if you can sort of take the thing that you've put together that should work and explore it, see what's going on, and figure out why it's not working, and then make changes to it. Okay, so that's a process called debugging, and we're going to work a lot with debugging in here. And by the time you're done with this course, hopefully you'll be pretty proficient at debugging programs as well. And if you can write algorithms and you can debug programs, right, you're in great shape. You're golden. So those are good skills to get out of this. The textbook is online. It's an open access free PDF download. There's nothing magic about this book. I'm not going to assign homework questions from it. Okay. There's tons of good resources online for Linux information. Unix has been around since the 70s. There's lots of information. So there's nothing magic about this one, but I like it. It covers all the material that we're going to be using, or almost all the material, and it seems like it's well written. So I've been using that for the textbook. The C primer from 121 is a good reference to have around, but again, C's been around forever. Just about any reference is going to work well. But if you still have your 121 book, right, that can be more valuable to go back and try to refresh your memory from, because that's what you were working through when you learned the stuff before. So approximate schedule, we have 11 weeks in fall quarter. We lose 5 days, so it's basically a 10-week quarter. Week 1, this is where we are right now. We're going to mainly concentrate on algorithms. Okay. Week 2, we're going to start getting into some Unix and look at programming in the Unix environment, so shell programming. It's kind of like writing C, but you don't have to compile. It's a little faster of a development process. Week 3, we'll jump into C programming. We'll review stuff that you've hopefully seen before. We'll review VI, everyone's favorite editor, right? And then we'll start moving forward with more advanced programming in C and in the shell, doing input-output operation, things like that. Week 6, we'll do some pretty high-scale debugging. Week 7, we'll talk about something called regular expressions, which is like a weird little side topic in Unix. But once you are fluent with regular expressions, your world gets much bigger all of a sudden. It's one of these things that when you have it in your tool belt, you'll find yourself using it all the time, even though you can live without it. And then at the end of the course, we'll just be picking up a whole bunch of other things. We'll do a little bit with GUIs week 9, and you'll actually have a group project you can work on where you're making graphical interfaces using some shell code. So all sorts of good stuff. Course outcomes, too many here for me to read, so I'll let you read these on your own. But these are the intended measurable outcomes for this course. All right, grading. So programming assignments, you're going to have 5 large programming assignments worth a total of 10% of your grade. Okay, and some of those will be in shell programming, some of them will be in C. One-day programs and homework, which we're going to talk about shortly, is another 10%, but these are short programs you'll do, again, in C or in shell scripts. There's going to be a small lab component to the course. I'll talk more about that tomorrow. But you'll have 5 labs that you'll do. They won't be nearly as intense as the labs in 250, 270. Okay, these are things you can sit down and probably do in an hour. But there'll be opportunities to take what you're learning in here from the software side and use it to do things like light up an LED or read a switch. Nothing much more complicated than that. So that's another 10%. Midterm 25%, final exam 35%, and then service learning project 10%. And service learning project is its own discussion coming up. Course policies, you can read these, but the basic punchline is don't miss deadlines. Okay, I generally do not accept late work. So first programming assignment, you have to turn it in a particular way, and if something messes up and you don't get it turned in right, I'll cut you a break in the beginning. But once you understand the deadlines and the process for turning things in and so on and so forth, pretty much no late work, okay? Unless you talk to me very far in advance or something extremely extreme happens. Support services, if you need or feel you would benefit from something like alternative testing, being able to test in a low distraction environment or with extended time, having a note taker, things like that could help you be more successful in this course. There are a lot of opportunities available. There's a disability support service over in Geyser Hall, and their whole mission is to make sure that every student is on an equitable footing with every other student. In other words, we want you to have every opportunity to do the best you possibly can in this course, in all courses. And if there's some situation that puts you on what feels like an unequal footing, we want to find a way to rectify that. So you can talk to me, you can talk to the DSS office if you feel like this is something that might apply to you, and we can go forward from there. College-wide policies, this one I like to read out loud in the start of courses. The Non-Discrimination Policy, and again, this is not just this course, this is every course that you take here at Clark. So Non-Discrimination Policy, and this is probably the only time I'll read from a slide, is today, because I don't do that normally. Clark College affirms a commitment to freedom from discrimination for all members of the college community. The college expressly prohibits discrimination against any person on the basis of race, color, national origin, disabled veteran status, sex, sexual orientation, age, gender identity, creed, gender expression, Vietnam era veteran status, religion, marital status, and presence of physical, sensory, or mental disability, and anything else that's not in that list. The responsibility for and the protection of this commitment extends to students, faculty, administration, staff, contractors, and those who develop or participate in college programs. That's all of us. It encompasses every aspect of employment and every student and community activity. Pretty straightforward, right? So treat people equally. There's a link here to Code of Student Conduct. I'll let you go ahead and click through that and read it. Everything's posted on Canvas. Keys to Success. This was my attempt at a shortened down version of my long-winded Keys to Success, but this is kind of like the stuff that's in that handout that I passed around. Class cancellation. Check the website if there's any doubt about weather or other events. And ECS course policies, there's a link through to that also. Yeah?
I'm assuming if you're like sick or something like that, you would send an announcement through Canvas or something?
So if I can't make it to class, I go on to the website and I put an entry in, and that should send an email to everybody. And it will also show up if you go to Clark's website and you look at class cancellations, it should show up on there. All right, so next topic is server access. So we use a different machine from what's used in 121. Okay, 121 you're using a CTEC server. For this course, the server is as follows: linux.engrcs.com. So engrcs.com is the main website for computer science and engineering here. This is also an alternative website for the program. So if you go to that site, you get a slightly more modern view of the engineering computer science program. I got fancy. It happens once in a while. So, and this has all the syllabi for the courses, so you can come down to 224 and there's the syllabi and so on and so forth. But that's also the entry for the server we're going to be using. So you can connect to this through PuTTY if you like. If you're using a Mac or Linux system, you can use SSH to connect to this. Whatever way you use to connect to CTEC, Clark EDU, you can use for linuxengrcs.com. Your username is, well, so here's my name. So my username would be first initial followed by last name with no punctuation. Okay, there's no period in the middle. And if your name has multiple parts, it's the first initial of the first part and then the last part. Okay, whatever comes after the space. If it's hyphenated, it'll be both sides of the hyphen. But I just went in through Canvas, and whatever the last piece is, preceded by a space, that's this part, and then first initial, all lowercase. And your password is your student ID followed by an underscore. So 10 characters, right? 9 digits followed by an underscore. And the first time you log in, it'll force you to change your password, but that's the only time I force you to change it. They don't expire. And it'll just ask you for your new password twice. So really important that you check to make sure you have an account and you can log in sometime today, okay? And if you do not have an account or you can't log in, send me an email, okay, and tell me that, and I'll set up your account later today. So I set these up about a week ago based on who was registered at that time. And if you registered after that, then you don't have an account yet, right? So just shoot me an email and we'll get you set up. But make sure you do that today so that by tomorrow's class, everybody is able to log on to the server. So for me, I log in there. I happen to have the name Nick, but let's not do that. So my name's Nick instead of N. Macias because I set it up first. But your username at linux.engrcs.com. Like I say, if you use PuTTY, just use the usual PuTTY one. And it'll ask you for a password normally. I've got it set up so it handshakes and knows my password. It'll ask you for a password, put it in, and you're good to go. All right, so this is the machine that you'll do most of your work on in this course. Okay. If you have your own Linux system, you're welcome to work on that. But I'm always going to test your code on this server. So if you're developing on your own machine, make sure you push your code up to the server and test it before you submit it. Because sometimes you have bugs in your code and they don't show up in one environment and they do in another. For example, on an Apple, in C, variables get initialized to 0 sometimes by default. But that's not an assumption you can make. On this server, they don't get initialized. So I have people turn in code that they think works perfectly, and I run it, and it blows up horribly. And it's because they forgot to set I equal to 0. Right? So make sure you always test your code up here. All right, so you can read the additional course policies. That's stuff I've mostly already talked about, but it's about late assignments and things like that. That's a link to the Linux text. This is a link to some sort of quick start information, basic Unix commands, information on how to access the Linux server, which we just went through, things like that. It also talks about something called Git. So how many people here are familiar with Git? Excellent. All right. So Git is what we call a source code control system. It's a way to keep track of versions of your code as you develop. And it was actually created for teamwork so that you could have multiple people working on a project, and multiple people could be working on the same files across time. So I'm making changes to a file. You come in later on and you want to work with that same file. How do you know that you've got the latest version that I just modified, right? So it's a collaborative tool, but even when we're doing work on our own, it's useful because it lets you create archives of your work and it lets you store them in the cloud. And so you can be at school working on one of these machines in here, making some changes and you push them out to Git, and then when you get home you can pull those down and develop locally on your own laptop and so on and so forth. And this is important for a few reasons. One, industry is really big on source code control. Okay, I had a student who graduated a few years ago and came back to give a talk to the engineering club, and somebody asked her, you know, what's your advice for students who are coming through the program right now? First thing she said was learn how to use Git. Right? This is just, it's a best practice kind of thing. And there's other source code control systems out there as well, right? It's not that Git is the best that will ever be, but the general practice of making backups of your code like this and keeping track of changes is a good one. I do no maintenance on this server, okay? I use this instead of CTEC because I want to run some code on it, and I wanted to sort of be free of like administrative details around Clark. But it's a service. I give them $10 a month and they run this for me. But no guarantees, right? It's possible that one day we'll wake up and the machine will be gone, right? And everything that you've written will be vanished, right? And if you don't have backups of this stuff, you're going to be in a bad place. So you always want to be making some kind of backup. Now you can take the code and download it to your machine and put it on a flash drive, right? That works. You can make printouts of it and plan to type everything back in if it gets erased or something like that. But Git is so quick and painless once you're used to it, right? It's really one command. You can make a shortcut for it. Just call it backup, and every time that you're at a stopping point, just say backup and walk away, and you're done. And it's out there in the cloud, and you can get it back from pretty much anywhere. So we'll play with Git in another week or two. We'll go into some details of that. And if you're already a Git user, right, then you can do your thing and just link in your Linux account. All right, so let's talk about one-day programs. Again, the basic idea here is to have these very short assignments that let you know if you really understand what you think you understand. So we might talk about the scanf function, which you use for converting a string for parsing a string into, say, a bunch of integers. And I'll stand up here and I'll talk about it and I'll show you some examples, and you can look at what I'm doing and it can make sense, and you can nod your head and you can write it down, and there's no confusion, right? But when you sit down and you try to write something that takes a string and converts it to a bunch of integers, it can be a very different experience. There's little details, right? It's like you can watch a million basketball games on TV, and then someone throws you a ball and says, okay, go out there and show me what you can do. If it's the first time you've ever held a basketball, it's going to be a very different experience, okay? So the one-day programs are an attempt to let you get that experience day by day, okay, as we go through the material. And typically there's 20 or 30 ODPs throughout a course. And like I say, if you know what you're doing and you understand the material, it might take you 5 minutes to do one of these, right? If it takes you 2 or 3 hours to do it, you're fortunate, okay, because you just learned something really fundamental by doing that. So ODP 401 is due on Wednesday. It's a 2-day program, even though it's a 1-day program, because I don't know if everybody's going to have Linux access until tomorrow. So 401 is a C program. And it's a C program which should print out hello world, uppercase H, uppercase W. That's all it does. Okay. Now theoretically that's very straightforward. It's you know, 1 or 2 lines of C. But to be able to do this, you got to be able to log on to the Linux server. Well, that's a few hurdles to clear. You have to be able to edit a file, which probably means VI or Nano or whatever your favorite Linux editor is. You've got to be able to compile it, right? And you've got to be able to do a print statement. So there's a bunch of things that have to happen to be able to get this to run successfully. And if you can do that in 2 minutes, great, right? But all the things that have to happen, if there's issues there, right, you're going to discover them in doing this. Okay, so I don't want to grade 70 students times 30 programs in a 10-week course. I don't have that kind of time. So all this stuff is automated. Okay, so there's an online system you can use to to do these assessments. So let me hop in as a guest. All right, so let's do ODP 401 for this test user. So I'm going to edit this program, mymain.c. And there's my program. I misspelled hello. Okay, so I'm going to compile this. And we'll be going over all this again. This is just kind of a quick run through. But to compile, right, GCC is the compiler. If you use the -O switch, it says whatever file I name next, that's my output file. So normally if you just say GCC mymain.c, what's your output program called? A.out, right? You end up with every program you write being called A.out, right? So here my output file is going to be called mymain, and the program I'm compiling is mymain.c. And it didn't complain, that's good. So if I say mymain, it says hello world. Okay, looks like I'm done with my assignment.
Do you have a strong preference for tabs and spaces?
Nope.
Brackets, right?
Nope. All right, so you want to submit this for grading, right? Because this is a graded assignment. So here's what you do. You use the command assess. So assess space, the name of your program, the executable program, space, and then the name of your source file. Okay, so you've compiled it yourself, you've tested it, it looks like it works fine. Now you submit it for grading. So you say assess, the name of the executable program, and the name of the source file, and hit enter. And it'll tell you, welcome to the automated assessment system. It'll show you your 3 command options, which is either submit your code, exit the system, or ask for help, which is really just those 3 lines of help. And then a little note down here saying, okay, you are about to assess your code for ODP 401. Okay, always make sure that this is running for the actual code that you think you're assessing. If you think you're assessing ODP 402, and you do this and it says, oh, you're about to assess for ODP 401, don't submit your program for grading, right? Because it'll clobber your grade for 401, right? So if you're in the wrong one, just go ahead and exit out. And it'll warn you you didn't submit your code for grading yet, that's okay, right? So make sure you're in the right one. And if you want to actually submit it for grading, just go ahead and use the G command. So hit a G and enter, and it tells you your grade, and you got 0 out of 10. Well, I got 0 out of 10. Okay, well that's kind of sad. So exit out and run the program. It looks good. It's an uppercase W, right? Which is why I said pay attention to uppercase. So we'll go ahead and change that. We'll recompile. We'll reassess. We'll submit for grading. Hey, we got 10 out of 10. All right. Once you get 10 out of 10, you're good to go. Just go ahead and exit, and you don't have to worry about ODPs until the next day, or maybe 2 days. You can do as many times as you want. It'll take the last one that you did. Right? So if you got this working, and you say, I'm just curious why that other one didn't work, and you regrade that old one, and you got a 0 out of 10, make sure you do the good one. Okay? Because it'll keep the last one that you submitted. Keeps a history of all of them, so I can always go back and look, but minimize the confusion, just keep the last one. All right, so you do that and you're good to go, and Wednesday ODP 402 will pop up. Okay, and you'll have 24 hours to work on that. So there's a link here to a YouTube video, which is basically what we just did here on the screen. So, but for a refresher, you can look at that. So questions about ODPs? Historically, I've never had a student complain about the ODPs before. I've had multiple students tell me that they were the most valuable part of the course. that it really, really helped them figure out what they knew and what they didn't know. And it helped them learn the things that they thought they knew but didn't. So much so that in 223, we only did a few ODPs, and I actually had students telling me they missed them, which was kind of amusing. So hopefully that works out well. And there shouldn't be too many glitches in the system, but occasionally things glitch out, or I do these early in the morning and it's just not working. So don't drive yourself too crazy, especially in the beginning of the term here. If you're positive your code is right and it's giving you 0 out of 10, right? Send me an email. And if you send me an email, send me your code. If you can copy and paste your assess session, right, and include that in the email, I'm very happy to take a look at what you've done and figure out what the issue is. And it's a chance that it's a problem on my end, right, that I set up the wrong assignment or something like that. But if you want to do that, right, you can come in here and just grab all of your code and just copy that and paste it into an email, and that's fine. And the more information you can give me, the more successful I'll be at figuring out what's going on. All right, so questions about that? All right, we got 6 minutes left to talk about service learning projects. So this is the other new thing to this course. This whole year, right, throughout 224, 22, 223, there's kind of a year-long project you're going to be working on. It's called a service learning project. And the SLP is a project you get to pick what you want to work on. You can work on it alone or in small groups, up to 3 people, as long as you specify why you've got 3 people working on this. And it's really a chance to sort of take some area that you're interested in, but you want to know more about, and say, hey, I'm going to do a project in this. And it's usually a fairly ambitious project. It's not something you would just do in a couple of weeks. It's something that's really supposed to take kind of the full next 3 quarters. And it takes your learning beyond what you're getting out of the classroom. It lets you go further than that and drill down into some area of interest to you. Why do we do this? Partially because there's a set of skills involved in doing this. For example, being able to set reasonable goals, right? So I'm going to invent, a new kind of artificial intelligence that's going to beat Google's AlphaGo machine. Okay, that would be a really cool project to do, right? It's not necessarily something you're going to do in 3 quarters here. Okay, so coming up with an idea, right, that's ambitious enough that it's going to be challenging and interesting to you, but knowing how to decide whether or not it's feasible, right, that's a really, really valuable skill to employers. As you proceed through this, being able to set up milestones along the way to track your progress and know if you're on schedule, behind schedule, and so on, that's a really valuable set of skills. So there's all these sort of non-engineering aspects to this that this can be a really good chance to develop. It's also an opportunity when you're talking to employers or colleges, universities, to set yourself apart, right? What did you do at Clark College? Well, I went to class and I got all A's and I didn't get in trouble. Okay, that's good. That's really good, right? But if you're applying for admission to, Caltech, or you're applying for some really killer job at Google, chances are everybody who's applying, everybody who's in that situation has the same backstory, right? They're the top students, right? So how do you set yourself apart? Well, I also was really into gaming, so I taught myself how to program Unreal, and I wrote a game, and here's a link to it, right? That's pretty cool, right? So initiative, self-starting, self-motivated, self-taught, those kinds of things, those are all really valuable. Right? And if you're really into gaming and you want to make a really cool game and you want to figure out how to use one of these engines, right, it's a perfect excuse. And it's credit, right? It's something you're required to do for this course. So if you can work on something and have fun and get credit for it, that's like the best of all worlds. So, so we can talk more about this tomorrow, but here's an overview of the SLP, right? Basically what I just said. And then there's a 1-pager down here. And what I'd like you to do is use this as an outline for an initial proposal, okay? This is not, get a pencil and fill in a few words in between each of these, okay? This is a starting point, it's an outline. But I'd like you to produce a document, as long as it needs to be, that covers these aspects of your project. So these could be like section headings, for example. And we'll talk more about this tomorrow in detail, but you can start looking at this and thinking about it. What kinds of things you might want to do. And the formal proposal for this is due on October 10th. So you've got about 2.5 weeks to get something submitted. And fall quarter, the real goal is sort of pinning down exactly what you want to work on. So it's finding an idea, it's answering those questions, putting together a proposal, doing some initial research, and then figuring out how you might want to adjust it, or maybe completely change it to something else. And hopefully by the end of this quarter, you've got a really solid idea, and then winter and spring, you just start doing the work and push it as far as you can. All right, so we'll start tomorrow going through some more details of the SLP, and then we're going to start talking about algorithms. So we'll start from there tomorrow.